a dimensional formula. Here the dimension, earlier videos we discussed about the units and as well as measurements, how to use the SI units, what is the rules of SI units, and as well as about the significant figures and rules of writing the multiple submultiple factors, what is the name of the multiple and submultiple factors. Already we studied about it. Now in this class, in this video, we are going to discuss about a dimensional formula. What is dimensional formula? How to write the dimensional formula for a quantities, physical quantities which has taken. That physical quantities which has taken the powers to which the fundamental quantity units are to be erased to obtain 1 unit of a derived quantity. 1 unit of a derived quantity means here as given that the powers to which the fundamental units means we know that fundamental units are mass, length, time with the fundamental units are to be raised to obtain 1 unit of derived quantity. If in case of the derived quantity which is expressed in terms of the fundamental units, means like for example velocity is there. In the case of velocity we will denote with meter per second. Meter is the physical quantity which is fundamental quantity, that is fundamental unit, means second is also fundamental unit. So that here we expressed in terms of fundamental unit, the derived quantity which is expressed in terms of fundamental quantity. So that's why here we can say that the powers to which the fundamental units, powers to which the fundamental is to be erased to obtain 1 unit of a derived quantity is called as a dimensional formula. In that case of some of the examples which has given that is a area for the small. The area means we will measure with the length into breadth. We know that length is also in meters and breadth is also in meters. Both are in the length. So that's why length and length. So length into length is L square. In terms of L square we can say that is m power 0, L power 2, t power 0. We know that m power 0 is equal to 1, t power 0 is equal to 1. There is no any value for this one. So only we can say that is L square. Means the powers of L be the fundamental quantity, fundamental unit. That is square which is the powers is to be for the physical quantity is to be which the physical quantity, fundamental units to be erased to obtain 1 unit of a derived quantity. We have obtained that this is a derived quantity. We obtained this derived quantity from the two fundamental units, that is the length and length. These are the fundamental units. In terms of dimensional formula means once again we can say that in terms of fundamental units, if we express the derived quantity, derived units in terms of fundamental fundamental units, then that can be said as also dimensional formula, because of we are expressing the derived values, derived units in terms of mass, length, time. These are the fundamental units. Mass means fundamental quantity, length means fundamental quantity, time is also fundamental quantity, which can be derived directly. They do not depend on another unit. So that's why the units can be called as here that are the fundamental quantities. The fundamental quantities, those from the fundamental quantities we are expressing the derived quantities. So that's why we can say that the powers to be which the fundamental is to be, the fundamental units are to be raised to obtain 1 unit of a derived quantity. This is the 1 unit of a derived quantity. This is by using the fundamental units we derived a derived quantity. And the next one is volume. The volume means we know that length into breadth into height. So length is also measured in meters, so that's why length. Breadth is also measured in meters and centimeters, so that's why that is also in length. And height is also measured in meters and centimeters, so that is also length. So in that case of length, 3 lengths are there. Length into length is L cube. The volume units are here we can say that L cube means length cube, meter cube. If we want to find out the length cube, then that is a meter cube. Meter means length, so that's why we are writing that L cube. These are the dimensional formula of volume is m power 0, L power 3, t power 0 be the dimensional formula of volume. Here the density, the next one is density. Density is having its units are the formula of density is mass by volume. Mass by volume is the formula. From that formula, mass can be measured in kilograms. Mass units are kilograms, and volume already we derived that is by L cube. L cube means that is a meter cube. Meter cube. Kilogram per meter cube, we can say like that. So that in the case of a kilogram means that is the weight, mass. So that's why m power 1. Mass is 1 is there, its quantity is 1, power is 1, obtained dimension of mass is 1, and meter be the length. So the length will be L power minus 3, means L be the length, meter is the length, so that's why we are taking L, the obtain the dimensions of powers is minus 3, so that's why L power minus 3. By taking the values m power 1, L power minus 3, these are the dimensional formula of density. Dimensional formula of density, which can be written as like this: m power 1, L power minus 3, t power 0. T power 0 is the 1. The value can be added like this. In generally, if we express the dimensional formula in case of the general for the physical quantity m power a, L power b, and t power c, like that, this eighth dimension is for the mass, and b is the dimension for the length, and c the dimension for the time. So in terms of mass, length, time, if we express any quantity, then that will be the dimensional formula of that physical quantity. So once again, the dimensional formula means the powers to which the fundamental units to be raised to obtain 1 unit of derived quantity, means to derive the 1 unit of a derived quantity, we will raise the powers of physical fundamental units. To find out the derived quantity, 1 unit of derived quantity, we will use the fundamental units. To express the derived quantity, will use the fundamental units. So that is called as a dimensional formula. Dimensional formula of that quantity, whatever the quantity which we want to take. So these are the examples of how do we take the dimensional formula of physical quantities. And some of the physical quantities are there. Let's see some of the another physical quantities. How do we find out further? By using the dimensional equation. Dimensional equation means one side be the physical quantity and another side be the dimensional formula for that quantity is called a dimensional equation. Let us see for some of the physical quantities. Here one side is the physical quantity and another side is the formula of physical quantity, and the dimensional formula which has given that is called as a dimensional equation. One side is the physical quantity and another side is a dimensional formula. By using the formula of any physical quantity, we can derive the dimensional formula or dimensional equation like this. Here let's see linear density. Linear density means we know this, mass by length. Linear means lengthwise, so that's why mass by length. Mass means it is measured in kilogram. Mass is measured in kilogram. Length is measured in meters, in SI units. Kilogram per meter. Whenever I am taken to the numerator, then kilogram per meter. From this formula, in terms of dimension formula means in terms of mass, length, time, we are expressing the any quantity. So that's why in case of mass means here mass kilogram power is 1 is there, so that's why mass power 1. And in case of a meter is the length power minus 1, so length power minus 1, that is t power 0. There is no any time function here, there is no any time dimension, so that's why we are taking that t power 0. By measuring these equations, we can write the dimensional equation by using the formula of the physical quantity. And some of the physical quantities which are having the same dimension formula, like energy density, pressure, stress, Young's rigidity, bulk modulus of elasticity. The type of physical quantities are having that same dimension formula, that is pressure, and pressure is also having their force per unit area is P is equal to F by A is the pressure. Then same as stress also we can get the same formula for that one. So the same dimension formula which we can get, that is m power 1 because of Newton per meter square below. Newton means here we can say that is a mass per kilogram meter power minus 1 into time power means per second. This is the formula for here we can say that is the value for total according to the pressure, and we can write this formula by using this formula. We can write that here m power 1, L power minus 1, T power minus 2. T power minus 2 means here time function is having the 2 dimensions. So mass kilogram power 1 and L means meter power minus 1 we are having, and second power minus 2 means kilogram per meter second square, kilogram per meter second square, which is we are having that. For that case of Newton per meter square is the formula. And sum of velocity and speed, both of velocity and speed having the same dimensional formula, because the formula is also same, that is a meter per second is the units, meter per second are the units. So that's why m power 1 L power 1, because of meter per 1 means L power 1 and second power minus 1 whenever taken to the numerator, then we can write that m power minus 1, that is meter per second. And in case of moment of inertia, that is kilogram meter square. Kilogram meter square means I is equal to mk square is the formula. I is equal to mk square. M is the mass, so that's why kilogram, and k square means we can get that from the length, so that's why meter square. So m power 1 L power 2, mass means kilogram, length square means meter square. So from that equation we can get that moment of inertia having the dimensional formula, that is m power 1 L power 2 T power 0. The next one is specific heat and specific gas constant, both are having the same dimensional formula, that is L power 2. There is no any weight for this one, because of we are taking specific heat and specific heat gas constants are depends on the vapor state, means also in moles. So that's why we can get that L square T power minus 2 into Kelvin power minus 2. Kelvin is also one of the fundamental units for the heat. Fundamental unit for the heat is can be get as a Kelvin. So that's why this is joule per kilogram Kelvin is the formula of specific heat and specific gas constant. The next one is the universal gas constant. Universal gas constant and joule molar specific heat formula is joule per mole Kelvin. Joule per mole Kelvin is the formula, and its dimensional formula is here that is m power 1 L power minus 1 T power minus 2 m power 1 L power 2 T power minus 2, and as well as here we are having the Kelvin, so K power minus 1, and the mole value is also there, so molar power minus 1. So this is the dimensional formula of a universal gas constant and molar specific heat. And a number of physical quantities are there. To know this, we can read some of the textbooks, we can get the many more etc., many more physical quantities for the dimensional formula also we can get. This is about a dimensional formula.